Get. There we go. And yeah, I'm gonna just hand it over to Kevin and Callum to take it away. We're gonna do some presentations again, some hand-on tutorials, and then we're gonna open it up for questions considering the topic today. So take it away, Kevin.
All right, thank you, Anne, and let me know, can you see my screen okay?
Yes.
Okay, great. So yeah, good morning, good day, good evening, everyone, wherever you are in your time zone. Thank you again for joining us in this second Erddap using Erddap webinar. In this one, we will be focusing more on using Erddap again with some demonstrations by Callum. But it's great to see everyone here and to keep this conversation going. So today we're going to do a few things. I just want to give you an outline of what's happening today. I want to give I'm going to start out with a few updates on Erddap developments, what's going on within the Erddap community, just for a few minutes, and then we'll jump into Callum's tutorial on using data from multiple Erddap servers. So not only will he show you, how to use data from Erddap, but this will also showcase kind of the power of this federated data system that you can build with these distributed Erddap endpoints. So he's put together some quick demo of topics, some that were requested through the survey. So thank you so much for filling out that survey, as Anne said, and please do so again so we have an idea of other topics that might be really of interest to the community. Next month, we will have another one of these, and we'll focus a little bit more on Erddap administration, things such as adding datasets to Erddap, modifying metadata in Erddap, dealing with the datasets.xml file in Erddap, some of these things that were also highlighted through the survey. So thank you for that again. But again, please continue to submit topics of interest so we have an idea of where we can help the community most. So just a few notes on Erddap developments. I wanted to kind of bring people up to speed. I'm sure many people are aware already that Bob Simons, who originally created Erddap, has retired. Bob did an amazing job putting this software tool together, developing it over the years, making it what it is, and we wouldn't be here without Bob. So he definitely deserves his retirement, and I hope he's enjoying that retirement. It did come as a shock a little bit. We were concerned, but we kind of pivoted to recognizing that this is really a great opportunity to sort of more formalize Erddap as an open source community project. To be clear, Erddap has always been open source. The code was always available. People have always been contributing code to Erddap. Bob was sort of the gatekeeper, the benevolent dictator for life there, as they call that sort of governance structure. So we're taking this opportunity to make it a more formal open source community project. We are lucky to have a new developer on board. Some of you may have heard his name is Chris John, currently working for the UC Santa Cruz. He has extensive history in software development, working with Google. He had been working at UC Santa Cruz for last few years and has been involved in the last few years in Erddap development, contributing tools and working with Bob to build the test suites and all that stuff. So he's very well versed in Erddap. He's a smart guy. He's a really nice guy. It's great to have him on board, and I'm thrilled to have him working with the community. In the process of doing this, we also wanted to kind of develop an overall sort of advisory group. So we're developing something called the Erddap Strategic Insight Group. And so what is this? It's not really going to be like a formal open source governance body. That's not really the tool that we need right now, we don't think. The goals really of the Strategic Insight Group are to kind of try to look for ways to make sure that we have Erddap sustainability for the long term. So funding for developers, funding for initiatives, that sort of thing. Also to promote Erddap to local, national, and global data communities, such as we are today. There's a lot of people using Erddap, so we want to ensure that they know how to use it, if there are any issues, we can sort of synthesize those for the developers and support the community by doing that in identifying these Erddap enhancements to make sure that Erddap continues to be the really useful tool that it is. In a sense, we want to sort of synthesize some of the enhancements, some of the discussions, so the developers are free to develop rather than sort of have to engage in some of those discussions and use up a lot of their time. So just finally on that end, this is, where you can find all the Erddap information now. Chris went ahead and created an Erddap GitHub organization. So there's a new home for the source code with the links there. This is where we'll be handling requests for bugs, discussions about enhancements, other discussions about Erddap through the discussions tool in GitHub. The documentation has been moved there as well. And there's also information on that link about the Strategic Insight Group and what it, more information about what its goals are, who the members are, and how one can get involved if one is interested in doing so. So those are the main topics I wanted to discuss this morning. We can move on to Callum, or if there are some questions, I guess, Anne, we can maybe take a couple questions. I haven't looked in the chat.
Yeah, there are currently no questions in the chat, but maybe we'll give everyone a minute while we switch presentations. Also, I will send all of the links out that are being shared in the chat and in the presentations via email right after this. I have all your email addresses through the registration. So.
Thank you, Anne.
Okay, that's
so I stopped sharing, so over to you, Callum, I guess.
All right. Have you got my notebooks up?
Yes.
Great. So, hello, everyone. Thank you for joining today. I'm Callum Rollo. I work for Voice of the Ocean in Gothenburg, Sweden, though today I'm at UH Texas, go Cougs. And in this session, we're going to go through some slightly more advanced Erddap usage, though again, this is for people consuming Erddap data. Kevin's going to cover more from the admin perspective next month. I know a lot of you joined us for our first session back in October. For those who didn't, the recording of that is going to be up soon. And all of these notebooks are kind of one continuous stream here. So if you click the link to that repo, you can download those and follow along at home if you're so inclined. I encourage you to do so either during the session or after. I just wanted to start with a couple of thanks to people who've made this possible. One is Felipe Fernandez of IUS. You might know him as Ozeanforschung. If you're on GitHub, he's a picture of a bucket. He created this Erddap library that makes all this analysis possible. And also my colleague Martin Moorman, who gave me a lot of feedback on these and provided some of the scripts that I'm going to show later. So on to the main topic of today. So in this tutorial, we're going to pull data from multiple Erddaps and use the data returned from run requests to build the next. So the idea here is if you're pulling multiple different data sets into one sort of coherent analysis. So at the top of the notebook here, I'm just pulling in the modules that I'm going to use, including mostly Erddap, which is the module Felipe wrote, and also some plotting tools. We're going to do some mapping later with CartoPy. And the first data set that we're going to pull is this MEOPS data. So these are animal-borne sensors, often on animals like seals. So you put like a CTD, you glue it to a seal's head, and it goes off and does work for you. So there's a big data set of these on the OSNC Erddap. So the first thing I do here is I set up our Erddap in the usual way. We give it the server address and we give it the protocol. It's TableDAP because this is time series data. And then I'm just going to search that whole Erddap just for the string animal. And that returns this table. It tells me, okay, on this Erddap, there's just one data set that has the animal keyword, and that's the MEOP animal profiles. I take that data set ID from this, and then I feed that back in to the Erddap. So I then get a data frame of this data set. And at first, I'm just going to pull the species column. So this is all the different species that are available in this animal tag data set. We've got various kinds of seals. We've got some turtles. We've got some not excellently standardized data. I see we've got SLE, which I assume is also the southern elephant seal. A couple of spellings for Weddell seal. I mean, as they say, like data cleaning is 90% of the job. But we're just going to pull the southern LE species for a start. So last month, we talked a bit about using constraints so that rather than pulling the whole data set from Erddap, which can take a lot of time, you send your request to Erddap with only the data that you want. So in this case, I'm telling it to only send me back data collected by southern Ellie, so that's the southern elephant seal, and within this range. So I've given it a longitude range, and I want only stuff from south of 60 degrees. So we're looking at a slice of the Antarctic Ocean, kind of south of South America. And for this quick example, I'm just going to pull the location of this data. There's a lot more data from these, typically CTD data. Some of the sensors are a bit more advanced. I think they sometimes have chlorophyll. But for the purpose of this script, I'm just pulling the longitude, latitude, the time, and the species, just so we can do a quick plot of where this data is coming from. So I run that request, and I get 34,000 rows of data. I think the full data set is about 500,000 rows. And then I make a little map. So here we see the Antarctic Peninsula, and this is a scatter of all our elephant seals. You can see where the data set ends. That's not because no elephant seal ever went west of here. It's just that's all the data that I've requested in this sort of geographical slice. And now here comes the chain part. So we've got this elephant seal tag data. And now I want to complement that data set, or maybe I want to check that the CTDs on these elephant seals have been well calibrated, or just fill out my data area a bit more. And the first place I always look for sort of corroborating data is Argo. So Ifremer have an Erddap server. There is also a dedicated library called ArgoPy, which if you're just going for Argo data is very useful, but we're going to use pure Erddap here. So I just set up a second Erddap instance, and all I've changed here is the URL of the Erddap server. Rather than OSMC, it's Ifremer. And I know that the dataset ID is Argo floats. I could have done the same as we did before, searching for the string. And I'm going to give it some constraints. And this time I set the constraints rather than having to set the box all over again. I just use the elephant seal data that we already have and use that to set the constraints. So I've taken the time from the elephant seals and I've used that to set our time window, because I'm not interested in Argo floats that were deployed like 10 years before the first elephant seal tag was put out. Likewise with the longitude and latitude, and I just get strictly the Argo floats within this area of interest and within this time of interest. Again, I'm pulling a pandas data frame. We see here we get a lot more data from Ifremer. What's that? That's over 1 million rows. There's a lot of Argo floats out there. And in this case, I've pulled all of the data. So we get all of the temperature, salinity, oxygen, turbidity, etc. And now I'm just going to plot those two data sets up together. So we see here, we've got the seals in black and the Argo floats in red. Obviously, the Argo floats don't go that shallow, whereas the elephant seals tend to stay near the coast. So this can be already quite a nice complementary data set. And you can see how the Argo floats are pretty strictly within the area of the seals. It's not perfect because this is using just kind of minimum and maximum longitude and latitude, creating this pseudo box, which this far towards the South Pole isn't really much of a square. But it works well enough, and it means that we're not pulling Argo floats from outside our area of interest. And we've already got 1 million rows. We wouldn't want to be pulling much more data than that we're not going to use. So this would allow us to make this kind of comparative analysis between the elephant seals and the Argo floats. And if that's not enough, we're now going to take a third server. So this time, rather than getting tabletop data, we're going to go for some gridded data. I'm using a JPL sea surface temperature reanalysis, which is coming from the Coastwatch Erddap. So this is a third Erddap instance that I'm creating. Notice that I'm changing the name of the Erddap instance each time. If you're just using one Erddap, I would just call it E equals Erddap setup. But this means I can have these 3 different Erddap instances in one script and keep getting different data sets from each of them. And this time I'm using the protocol Erddap because this is gridded data. As we discussed last month, Erddap treats tabular data, like anything that can be kind of envisaged as a time series, and this multi-dimensional gridded data in a very different way. So as well as supplying the dataset ID, we also need to call this GridApp initialize function. And that tells us what are the physical constraints of this dataset, so we don't try and request data that's outside of those constraints. And again, I'm going to change those default constraints by setting the time and the area just equal to the area that's covered by our elephant seals. And I'm also changing the steps here. This is an extremely high resolution data set. So I'm setting a time step of 365. So I'm just getting sort of like an annual snapshot of sea surface temperature. And I'm coarsening the longitude and latitude by a factor of 10. This is just so that this script runs in like less than an hour. I get that into an X-ray object. So rather than a pandas data frame, this is a multi-dimensional array. Let's just have a quick look at data set so you can see that. So we have this X-ray object. We see we've got 10 time steps because these elephant seal data covers about a decade. And yeah, we've got 150 points in lat, 300 points in lon. And when we plot it all up, we see that that sea surface temperature covers exactly the area that we requested and nothing more. So again, if we wanted to sort of corroborate our near surface data from our elephant seal tags or from our Argo floats, this is how we'd do it. So this is all being run assuming that we want data from elephant seals. And I just want to demonstrate something quickly. I hope this is going to work in an appreciable amount of time. What I'm going to do here is I'm going to scroll all the way back to the beginning of the notebook. And where we selected our species, rather than the southern elephant seal, I'm going to substitute that for the crab-eater seal. And then I'm just going to rerun the whole analysis. So the idea here being that if you've run this analysis once and you want to change something, maybe you've slightly adjusted the bounds of your study area, maybe you've got a review back and they've said that they want you to go back an extra 10 years in time. Maybe you've just written a bunch of scripts that do this and you want to move to a different study area or to a different species. The advantage of chaining these requests to different Erddaps together is that it means if you can just change the initial request and just get the crab-eater now looking at a different animal. And then when you make subsequent requests to the other Erddaps, those requests will also be changed. So if you have an animal that has a sort of different location or a different feeding pattern, you don't then have to go and re-download the whole Argo dataset, manually set all of your bounds. Okay, I'm slightly stalling for time because this download is taking a while. Please bear with me. There we go. Okay, crab-eater seals. So there's not so much data from this data set, and we can see it's much more by the coast. They're not delving into such deep water as the elephant seals are. So now we should also see that our Argo data set is much smaller, and now it's only 35,000 rows rather than over 1 million. And again, this is the slight limitation of this is you still have to request a box from Erddap. You can't give it like an arbitrary KML bound. I think someone has requested that, but someone needs to work on that if you want to start passing arbitrary shapes for Erddap to do geographic subsetting. But again, you see this time we get a much smaller slice of SST. So that it's responsive to changes. So that's why I would encourage you, if you're pulling data from multiple Erddaps, you can really make use of these constraints. It's something I actually didn't do for a while. When I started using Erddapy, I would just request a whole data set and then do the subsetting locally. But especially once you start pulling this reanalysis data, it's much faster and it's a much more efficient use of resources to have Erddap do the subsetting and just pull the data that you need. Yeah, so there's some links down here to the original data if you're interested in MEOP or Argo. things like this. And I've also linked to the Erddap documentation, which has a lot more info on using Erddap's inbuilt search. And there's some more things there on how you can use constraints and variables. So that was the main notebook for today. What I'm going to talk about now is some sort of requests that we've got. I know Anne has said several times that we have this survey out that we're very much looking for feedback. What are you struggling with Erddap? What would you like to understand more? Either from libraries like Erddap or how best to get data. So I'm going to answer some of those questions now. So this is a bit of a mismatch of data. So one request we had was how do you get metadata from Erddap? From which I understood, how do you get like rich metadata from a specific data set or from multiple data sets on a server? So Erddap has this function to_NCCF, which I think is a NetCDF climate forecast standard, which gets you back this metadata object. So this is in place of to_pandas or to_Xarray. You just do this to_NCCF. And you get this NetCDF for dataset objects. And this has all of your metadata. We can see we have the contributors here, the time series type acknowledgements, a bunch of spatial data like the extent, the history of how this was made, all of the keywords, a list of variables, which can be quite handy. This little block of code here is just me taking this object and passing it into a dictionary so that it's a bit easier to act over. For instance, if you then wanted to do a search on this or some analysis on it. So I just go through the keys in it. If it starts with an underscore, I discard it because that's typically a method. And yeah, we then make a nice Python dictionary called atts. And so this is a dictionary of all of that data. And this is as you saw, this request is very fast. This NCCF, even if it's a very large data set, it's just getting you the metadata that you might need. Another request we had was to display some vector data. So I went for a hunt on the Coastwatch server and I found some HF radar, which is a nice example of vector data. So this HF radar, that's typically sea surface currents. You get like a sort of 2D gridded field of of sea surface currents. So the usual, I set the server, the protocol, the dataset ID, and grid app initialize. Let's look at the constraints. Okay, so this is covering an area of about 20 degrees latitude and 15 degrees longitude. That's quite a lot. So the first thing I typically do with a grid app request is I will reduce the longitude and I'll increase the longitude and latitude steps so I get about 1,000th of the resolution. Erddap's not support item assignment. What did I do there? Sorry, we're about to do some live debugging. Oh, sorry, that should be a colon. Okay, there we go. Sorry, I'm just going to rerun that so that I get the original result. So, apologies. So I've coarsened it. So I'm taking every 100th point in lon and every 100th point in lat so that the request to the server goes a bit faster. As you can see, it's still taking an appreciable amount of time. But if you don't know anything else about the data set that you're requesting, this step of coarsening is a good way to make sure that you're not waiting overly long. Okay, we got there in the end. Right. So we can see from this HF radar that most of this is sort of blank space. I guess this is probably the western seaboard of the US from the shape of it, and we've got some little points of HF radar data, because this is a data set that has multiple HF radar stations. So I'm just going to focus it on this section up the north end here. So I set my constraints again. but this time I give it very fine longitude and latitude constraints, so it's a small area. And now I can set my longitude and latitude steps to 1, so we get the full resolution HF radar data. So this is just a quick X-ray plot of the eastward velocity. So red values is water moving east, blue values is water moving west. Not so intuitive. So what I do when I want to plot vectors is I use matplotlib quiver. So a quiver plot looks like this. We're using cartopy for the background so that these are properly to scale. This is a local equal area projection. And we just plot these little arrows. You got a little scale here of 1 meter per second. So that gives you more of an idea of these little gyres and other funky little features that are going on. I'll take questions at the end, I think. I'll come back to you in a moment. One of the other requests we had was for displaying satellite data. So we're going to use the Pathfinder satellite. Again, Coastwatch is a really nice resource for various high-quality gridded data products. It's GridApp. We run a GridApp initialize. And again, same trick. I just coarsen my data so that I could then get a bit finer with it. So we've set our constraints here, and we can see that, okay, this is sort of a sea surface skin temperature. So now you could pick an area of interest, zoom in on it, and start refining this. So let's do that now. So you can set the constraints 1 by 1, as I've done here, or you can just do constraints equals. You can just copy this dictionary that you get by requesting constraints. And it's often easiest to just copy the dictionary and edit the items, because that means you won't get the key wrong. Like, you got to have these little greater than equals formatted right. Otherwise, Erddap won't like your request. So let's go and look at some sea surface temperatures. Let's set, I don't know, where is the North Atlantic? That's like, I guess, 40 degrees north to 50 degrees north, and longitude, let's say minus, so it's really testing my geography, longitude like minus 60 to minus 30. And I'll start with steps of 10 rather than 100, just to get a slightly finer result. Okay, yeah, looks like, you see what I think this should be the Gulf Stream here. I don't know, it's been a while since I was a real oceanographer. I mostly just write code now. But now that I know the area I want, I reduce those longitude and latitude steps to 1, and we see that really fine-grained data. I guess this is a cloud mask where you've got these white values here. So yeah, that's just very quickly how I go about accessing GridApp data. I remember that, as we discussed last month, by default, GridApp will just return the most recent time slice. If I want to go back in time, I change these time values up here. So let's see what this area was doing back in May. Okay, you can see it was a bit cooler, as we would expect. Yeah. So again, just to show you that SAT object, it's an X-ray data set. It's got a few dimensions. We have values in longitude and latitude. There's only one in time, because again, we were just requesting the most recent time slice. If I extend those time slices to go from May to June, oh, didn't like that. Oh boy. That's because I was applying to plot a multi-dimensional array without first subsetting. Okay, so now we can see the satellite has got 2 time steps because it's a monthly product. You could extend those time bounds to go back in time. But again, coarsen, find your area of interest, then get the fine-grained response. A few more requests I got. Several people asked about how to access Erddap through MATLAB and R. I don't use either of these programs, but they are very popular. So I will try my best to answer this. Probably other people are more qualified than me. One thing I will say is my immediate response is use Erddap. If you at least have a small amount of ability with Python, or one of your colleagues does, I would encourage you to use Erddap download your data, and the way that we demonstrated with these notebooks, you could easily copy these and adapt them to your needs, and then just save them as an open format. So on the left here, you'll see my local files. There are these notebooks, environment, etc. What I'm doing here is I'm just taking one of these data sets, getting it to pandas, and I'm writing a CSV file, which will pop up here in a moment. So though, if you write either a CSV file from pandas or a netcdf, if we've done this to Xarray, you get a nice standardized format that most computer programs can read. So you can just see now we've got that data in a CSV. You can open that straight up in Excel or MATLAB or what have you. Alternatively, you can slightly abuse Erddap to make use of Erddap's to map file functionality. So here I get the download URL, which would usually be in HTML, and then I just replace .html with .mat. So again, remember, all that Erddap is doing is creating the URLs that Erddap needs to produce your data set. So I'm just doing a basic full data set here. I could do all of my funky subsetting and variables and things, in which case this URL will become much longer if we're just requesting a subset of data. Erddap will do all of that processing for you and spit out a mat file. You could just click this link and it would download. There we go, got a nice little .mat. Or if you wanted to do it within a script, you can use requests. And that's what I'm doing here is I'm getting Python to send the request to Erddap, get back the mat file, and just write it as a binary file here, which will pop up in a moment. So there we are. There's that nrt.mat file. And just to see what that looks like, I'm going to use scipy.ios to read that MATLAB file. Like, don't do this. There's no good reason to read a MATLAB file into Python. But if you did, here's what you get. You've got a MATLAB 5.0 file. It has the metadata. It has the data in there, just as you would have had from pandas or what have you. So even if you're not a Python programmer, I still hope this library can be useful for you in creating these requests, curating those URLs and sending them to Erddap. Then you can just save it in whatever file you like. Or you can go to this Erddap that I found that just serves up binary .mat files. I think they're XBT profiles. So, you know, maybe there's an Erddap out there that's just made the format just for you. On R, I've made a notebook for that. I don't know if you notice about these are Jupyter notebooks. The reason it's called Jupyter is that they are for writing Julia, Python, and R notebooks. So you get the same format, but this notebook is running an R kernel. So I'm going to show here the R Erddap package, which has very similar functionality to Erddap, but is written in R. Again, this is thanks to my colleague Martin Moorman, who wrote this. So you can see the syntax here is very different to Python. Whenever you see these little left ticks, that's telling you you're probably running some R code. But it's very similar. You need to import the library. You need to set the URL of your Erddap. You need to give it a dataset ID. Remember, we looked at this all datasets last month. This is a special dataset, which is basically a table of all of the datasets on that Erddap. And then we download it. And here we have, so we have each row represents a data set. It tells you the data set ID, the institution that made it, the longitude and latitude bounds, all that good stuff. And then if you want to get a specific data set, you can request the info, similar to that metadata fetch that I showed earlier, or you can get the data set itself. So similarly here, we're asking for a subset of fields, and we're putting it into a table. So the glider info looks like this. I actually really like the way that our Erddap represents these. It gives you the valid range for each of these values. For instance, angular CMD, this is a glider data set. So that's telling you that the position of its angular motor can only be between pip rolled 70 degrees to port and 70 degrees to starboard. It'll tell you the range of chlorophyll in this data set, minus 2.5. That's not great. I'm sure I flagged that. That's fine. And then you can have a look at glider itself. which very much like a pandas data frame, we've got our only the variables that we've requested here. Yeah, so if you're using R, there's a very nice function for that already. I had a look around. I couldn't find a MATLAB library that does this. Maybe someone's written one. If so, let me know and I'll include it in the next presentation. And there are a couple of other questions which I think will take a bit more answering. I had a couple of requests about Erddap visitor analysis from a couple of admins last time. I've written that up into some notebooks. I'm just going to very quickly show those. This is going to be a future tutorial though, but the link is here. And if you're interested, this is just showing how to pass logs, which was fun for me to learn. So basically if you're running an Erddap server and you want to know who's visiting your server, what are they requesting, when are they coming, you know, all that kind of stuff. As I said, I'm going to record a proper video on this later, but basically we fetch information on the IP addresses to tell us the location of our visitors. We do some analysis, we drop some bad requests, we do some analysis. So this is useful, for instance, it tells you which are your most popular Erddap data sets and most popular data types. So if you want to know, you know, are people requesting CSVs or netcdfs? Is anyone using those .mat files that I've been serving, things like that. And then at the end, you can make a cool little map of where are people visiting your Erddap from. Yeah, some really weird stuff in there when you start digging into it. Like you suddenly get a huge spike of traffic from some place that you've never heard of. It's fun. I don't know, maybe after this session, I'll see if any of you guys have been following along at home and downloading some of these data sets for us. And I also had a question about computation and data handling in a cloud environment. I wasn't sure entirely what this referred to. But one useful thing that we use in our organization is called the Littlest Jupyter Hub. So if you really like these Jupyter notebooks, but you don't fancy the faff of installing them on your own computer, or you have security policies that prevent you from installing lots of fun new programs from the internet, what you can do is ask the admin at your organization to set this up. It's very quick, extremely easy. What it does is if you have a computer within your network, you can then host Jupyter Hub on that and have individuals having user accounts. So if you have, for instance, an internal Erddap server or other internal data sets that you want people to be able to access, maybe their computer's a little resource limited, you can set this hub up and it means that anyone can just log in, run data analysis on this, you know, like having like a high performance computing cluster, but rather than having to write like arcane bash scripts, you can just use this pretty Jupyter interface. Highly recommend it. Go and check that out if you need to run your own internal cloud sessions. Okay, I think I've spoken for long enough. I'm going to stop this screen share and we'll take some questions.
Okay, just a quick reminder. I'm gonna, if people want to raise their hands, if they have a question, I can elevate them so they can speak. This is unfortunately not as straightforward in the webinars, and I think we'll consider switching to Zoom meetings so you can see each other and it's a little easier to accommodate people speaking up. But yeah, go ahead and either put your questions in the chat or raise your hand. There's one quick, never mind, it's already been addressed. Kevin, go ahead.
Yeah, thanks, and thanks, Callum. That was really fantastic, and there's a lot in there. So I'm glad that these are recorded, so people can go back and watch these at their own pace and sort of follow along. It was really great. I just want to make a note when you were going through the metadata and showing how to look at metadata. That was great. For all the data providers out there, one very important attribute in the metadata is the license. It's very important to have your data license clearly specified. There is a default license that comes with an Erddap installation, and what we have found, and this is an issue when we're trying to federate these distributed data sets, but what we find is a lot of people just tend to use the default license and not change it, and that's not ideal. So definitely put in the license that is relevant to your organization and your data set. It's extremely important so people know how they can use your data. If you don't have a license, that basically means you can't use it. So it's important to have a valid and correct license in the attribute. So thank you.
Absolutely. There's a question in the chat. Do you perhaps have an illustration on the reading of MATLAB files via Python?
For reading MATLAB files, I just use the SciPy IO library that I quickly showed there. It's not something I've had much experience in, and it's something I find quite painful to do. So if anyone else is better at that, feel free to link to that. Sorry.
Also, just as a quick heads up, because there were some questions about, MATLAB and R, and it seems like Roy and Kara are pretty familiar with that. If anyone's interested in hosting a webinar addressing other topics, including this, we'll get in touch with you, or you get in touch with us, and we can organize something to accommodate everyone's needs.
Yeah, I noticed that Felipe has put several messages in chat with much more competent instructions on how to read MATLAB into Python. So yeah, get used to Googling an obscure science IO question and having him answered it 5 years ago on a forum somewhere.
Awesome. Thank you, Kara. She signed up and doing a seminar on R, so we'll be getting in touch and setting that up. Okay. If there aren't any questions coming in right now, please continue to put them in the chat or raise your hand. I'm going to give a little bit more time to react. I know this is a lot of information, so no worries. But maybe in the meantime, while we're waiting for people to ask their questions, maybe want to briefly talk about what we're going to focus in the next webinar. Maybe we'll just use that time to kind of address that.
Yeah, thanks, Anne. That's a good idea. So right now, we're going to kind of look at right now we're planning to look more at the administrative side of Erddap servers, really focusing on integrating data sets into Erddap. So we'll look at different types of data sets, NetCDF data sets, CSV data sets, how to configure them into Erddap, how to modify metadata, how to get them working, those sorts of things. We'll also have a discussion about the datasets.xml file and how it's possible to sort of break it out and make it a little bit more easy to handle. So Callum will talk about that. But if there are other topics that people want to hear, is there a survey link, Anne, that we can put in so people have a link to the survey to fill out, and any other topics that may have come to your mind as you were watching this presentation today, or since the last time you may have filled out that survey, would be great. And then we can sort of pick some of those out that we can address as well. Thanks for adding that link in there, Anne.
Sure. I'm also sending it after the meeting. I'm preparing the email and trying to copy all the links from the chat. So, there's a question in the chat. Has anyone developed a notebook to provide a summary of the database being served on an Erddap server?
Oh. Yeah, that's a good question, Hugh. Every Erddap server has a link that shows you the sort of summary of all the data sets in that Erddap server. Whether or not someone's actually used that data set link, that link in Erddap to summarize data, that's a good question. That would be a very useful thing to have, I think. I don't know, Callum, are you aware of anything like that?
Not so much on providing like a high level overview of all of the data sets, but one of the notebooks that I showed last month was sort of searching and finding data sets within Erddap uses that. Where, as you say, we download that all data sets table and use that to find data sets that might be within a geographic area of interest or might have variables of interest. There are a couple of services out there that try to search across multiple Erddaps, which can provide a similar functionality. But yeah, that's a good topic for a future presentation, I think. So yeah, I'll add that to the list.
And Roy mentions that our Erddap can do a lot of that summarization, which is something I'm not familiar with. So that's good to know, and maybe that can be part of the R demo that Kara is willing to give. That'd be great. Thank you, Kara.
There's another question coming in. Hi, Callum. Have you ever tried to stream NC into Python Iris library?
I haven't used Iris myself for this. I don't tend to work with a lot of gridded data and certainly not much sort of like very large out of memory data. But that is something I can look into for future tutorials. Yeah. And yeah, just in response to Jeff, I think Erddap was very much designed as mostly sort of machine-to-machine data distribution portal. So yeah, the HTML pages look awful. I don't expect that to change. So very much good to script against Erddap rather than trying to click through all of the boxes.
Yeah, and that's a common comment we get from lots of people that are just starting to use Erddap for sure, and agree. The HTML pages are super useful to understand how to build your scripts, because you can try to click things and add in, constraints and add in server-side functions and see what that looks like on the URL, and then take that back into your scripting tool of choice. But it definitely is much better to use something like Python or other tools which we can show, demonstrate kind of on top of Erddap, that use the Erddap services to provide, visualization tools on the data. But the HTML2 definitely has its place to sort of figure out how to create those Erddap URLs.
Are there any follow-up ending words of wisdom? If there aren't any more questions coming in.
No, I would just say thanks for everyone for joining and staying with us for this. Oh, one more question coming in, Antonio. Oh, you want to specify the version, right? Yeah. So, in terms of the versions, boy, Roy might know this better than me. But Erddap supports NetCF version 4 Classic. Is that right, Roy? Sorry to put you on the spot. Can Roy talk?
Yep, I just elevated him if he wants
Thank
to.
you. Sorry to put you on the spot, Roy.
It's okay. Are you talking about reading or writing? Reading it can do NetCDF 4 or 3. In fact, anything that the NetCDF Java library can handle. So it can handle grib and buffer and the like, if NetCDF Java can read it. Writing, it only does NetCDF 3. The ability to do 4 is actually in there, but commented out. And the problem is that you have to link into the C code.
All right.
We may come up with a version of that for people. That's sort of on our list of things to look at. So the ability is actually built in there, but it's commented out and doesn't get into the builds. And what we're trying to avoid is installing the C code for NetCDF can be a real hassle. And we lose the ability just to have the WAR file, which makes it so easy to install. So.
Yeah, thank you, Roy. I remember now, we just had this conversation a couple weeks ago at the IUS, the US IUS data management meeting, and yep, thank you. That is a complication.
Yeah. It's something that's on our radar, so I appreciate the question. But serving, yes, it can serve NetCDF 4. That's not an issue. It can serve grib.
Thank you, Roy.
Okay, I think if there aren't any other questions at this point, we can kind of wrap up and give people a little bit of time back. I'll extract everyone's email address, and I have the email prepped with all of the links that were shared also in the chat. So you will see an email from me in a minute. And hopefully we'll see you at the next webinar in a month. The link is also in the email address, and I put it in the chat. So if you haven't copied it yet, it will all be in the email, and then we'll go from there. And please give us some feedback on what you want to hear for future seminars. This is really helpful to hear from the community what is helpful to you and what you need to continue working with Erddap. So yeah, keep in touch. Thanks everyone for joining.
Thanks everyone.